Hi, I'm Liu Lb. I joined Hong Kong U starting from July 2024. My research interests are climate change and carbon neutrality. Remote sensing plays a fundamental role in my research. I'm not developing remote sensing algorithms or products. Rather, I'm mostly applying remote sensing to solve the scientific question that interests me in my research. Let me give you some examples. As you know, carbon neutrality is a balance between carbon sources and carbon sinks. On the side of carbon sources, the energy system is the largest carbon emitter, accounting for about 80% of carbon emissions globally. So, decarbonization of the energy system requires unprecedented amount of renewable and low carbon energy, such as solar energy. To make a better use of the low carbon solar energy, we need to understand the spatial distribution and the temporal dynamics of solar radiation and associated solar energy. Installed radiation stations are very scarce worldwide. For instance, in China mainland, only about 200 plus radiation stations are publicly available. We leverage remote sensing to derive spatially continuous observations of solar radiation and then convert it to solar power generation, which greatly supports my research. On the side of carbon sinks, the land ecosystem mitigates about 30% of anthropogenic carbon emissions over the past 60 decades. However, how this critical carbon sink will evolve under climate change is still largely uncertain due to our limited understanding of land ecosystem. Anti-Coriolis flux towers are recognized as a vital tool to measure ecosystem breadth and state. Still, a limited number of flux tower sites are available due to the high cost, especially in tropical forests. In my research, I make use of innovative satellite observations of solar-induced chlorophyll fluorescence, which opens a new avenue for spatially continuous retrievals of ecosystem growth primary production (GPP) with unprecedented accuracy, resolution, and coverage. One of the most important discovery of my research is based on SIF, in which I identify the dominant role of soil moisture in determining the dryness stress on the land ecosystem.